Hi everyone, my name is Shannon Reaver and I work for Facts based in Stellenbosch. And today I'll be presenting on the topic contaminants in staple cereals. What should we be concerned about? Contaminants in staple cereals are a major food safety issue worldwide. This is because staple cereals are heavily relied on for global nutrition, contributing up to 70% of the world's food energy intake. Maize is the most produced cereal globally, followed by wheat, rice, barley, sorghum, oats, and then rye. There are various different types of contaminants that affect staple cereals. These include natural contaminants, heavy metals, processed contaminants, environmental pollutants, and residues. Mycotoxins are undoubtedly the most well-documented contaminant in staple cereals, so it would be unjust not to briefly touch on this contaminant. Mycotoxins are toxic compounds that are naturally produced by some fungi as secondary metabolites. The risk of mycotoxin production significantly increases when cereals are stored in warm, damp conditions. Therefore, post-harvest cooling and drying of cereals is an important preventative strategy. The Food and Agricultural Organization estimates that 25% of the world's cereal production is likely to be contaminated with mycotoxins. Refining cereals typically reduces the presence of contaminants. However, mycotoxins are an exception to this rule. Mycotoxins are chemically stable and tend to survive food processing. They also may accumulate to harmful levels in staple cereals without having any adverse effect on the flavor or appearance of food. Therefore, they are a major food safety concern. Mycotoxins are, however, very well regulated. Although this doesn't necessarily lower the safety risk, it does give consumers some peace of mind. Beyond mycotoxins, there are lesser known contaminants that may pose as greater risk to public health. This presentation is largely going to focus on one of these contaminants, and that is arsenic in rice. It might be important to first define the types of arsenic that we find in the environment and in food. For public health relevance, arsenic is categorized as organic arsenic and inorganic arsenic. Organic arsenic is not metabolized by the body and thus does not pose a human health risk. Inorganic arsenic, however, has a high bioavailability and is toxic and carcinogenic. Studies have shown inorganic arsenic to constitute up to 85% of the total arsenic in rice. Arsenic has been shown to be a major contaminant of rice. Compared to other crops, rice has an unusual efficiency to absorb arsenic. Rice has been found to actually absorb up to 10 times the amount of arsenic compared to other cereals. This is hugely problematic as rice paddies are often heavily contaminated with inorganic arsenic due to the use of arsenic-based pesticides in the 80s and 90s. Although these pesticides have since been banned, arsenic still lingers in paddy soils. Inorganic arsenic levels have been tightly regulated in drinking water for many years, with the WHO, EPA, and FDA defining a maximum tolerable limit as 10 parts per billion. However, global regulatory bodies have been very slow to regulate arsenic in rice and rice-based products, despite numerous studies highlighting that it is a potential issue. Maximum arsenic limits for rice and rice-based products were only defined by the European Commission in 2015, the FDA in 2016, and South Africa in 2018. The European Commission sets maximum inorganic arsenic levels for a variety of rice and rice-based products, namely white rice, husked rice or brown rice, rice waffles, wafers, crackers, and rice cakes, and also rice destined for the production of food for infants and young children. The FDA has established an action level for inorganic arsenic in infant rice cereals of 100 parts per billion. The FDA does not set maximum arsenic levels for any other rice products besides that of infant rice cereals. To clarify before we go on, all the limits in the regulations are reported in parts per billion. This is the same as 1 microgram per kilogram or 0.001 ppm or part per million. Within South Africa, our regulations set a maximum level for both inorganic arsenic and total arsenic of 200 ppb in white rice and 350 ppb in brown rice. All right, so how big is the problem? If we look at studies done around the world in the last 10 years, the average total arsenic concentration tends to be below 300 ppb. Relative to the limits set by the European Commission and the South Africa's Department of Health, this seems all right. There's a definite trend of higher arsenic levels in brown rice compared to white rice, which is reflected in the regulatory limits. But are these limits enough to protect all groups within the population? If we look at 3 studies comparing total arsenic contents in inorganic versus non-organic rice, in organic versus non-organic rice, another trend is visible. Organic rice tends to have a higher arsenic content for both white and brown rice varieties. To investigate this issue locally, FACTS purchased a variety of rice products and analyzed them for total arsenic. The trend of brown rice containing higher arsenic levels than white rice was observed. Non-organic white rice had higher total arsenic levels than organic white rice, which was not what the other studies observed. However, this could just be due to the small sample set. For brown rice, the trend of organic rice containing higher total arsenic levels than non-organic rice was observed. The average total arsenic content for all samples was 164 parts per billion, which is well below the South African regulatory limit. Although this is reassuring, it's important to note that South African regulations do not currently define a limit for total arsenic or inorganic arsenic in infant rice foods. This lack of regulation is a major cause for concern, as firstly, rice is known to contain high arsenic levels. Secondly, rice-based cereals are a highly popular infant food due to their low allergenic potential, high palatability, and good nutritional value. And thirdly, inorganic arsenic-related health effects are reported to be exacerbated with early life exposure. Focusing on this last point, the FDA estimates that eliminating rice products from the diets of infants and children up to 6 years old could reduce their lifetime cancer risk by 6% and 23% respectively, which is quite crazy. Other health effects due to infant inorganic arsenic exposure include suppressed cognitive development and stunted growth. With this concern, FACTS tested 5 locally available infant rice cereals for total arsenic. 2 of the 5 cereals had total arsenic levels exceeding the 100 parts per billion limit set by the European Commission and the FDA. Inorganic arsenic levels were not determined, but as we mentioned earlier, it may comprise up to 85% of the total arsenic content. Thus, the theoretical inorganic arsenic levels may be up to 110 parts per billion in brand D and 128 parts per billion in brand E. So these samples are definitely of concern. Worldwide, similar reports have been reported. A US study found 23 rice-based infant cereals to contain an average total arsenic content of 174 parts per billion. And in a Spanish study, another sample was found to contain 310 parts per billion. A UK study showed similar organic versus non-organic trends. Out of all the samples tested, only the non-organic rice cereals were actually within the 100 ppb limit. Beyond infant rice cereals, there may also be a risk for whole rice should it be consumed by infants and young children, either as is or further processed. If we look at the findings by FACTS, 21 of the 25 samples analyzed actually had a total arsenic level exceeding 100 parts per billion. These findings highlight the urgent need for local regulatory authorities to define a maximum level for inorganic arsenic or total arsenic in infant rice foods. Without such a limit, the health of this vulnerable population, whose food choices are very often not their own, is largely at risk. In summary, contaminants in staple cereals are a food safety concern, with infants being a particularly vulnerable group. And this is purely because contaminant toxicity is dose-related and dependent on body weights. And infants typically consume cereals as a staple food, and the dosage per kilogram is then significantly greater as that consumed by a 70-kilogram adult. Arsenic in rice may pose a great risk to infants. The arsenic content in rice varies according to the type of rice. So brown rice typically has more arsenic than white rice, where it's grown, and how it has been cooked or processed. So uncooked rice typically has higher arsenic content than parboiled rice. Regulations should also cover all rice products. Commercial products should be tested regularly to ensure the health of the public, and the public should be made aware of the potential health risks. Thank you.